Welcome to the Advanced Computer Architecture course. I am Deepika Dev, and in this video I will explain how processors are implemented in gem5. I will also give some insights on how to solve the first assignment of gem5. Assignment 1 deals with processor or core optimizations. The optimizations are provided as parameters into the gem5 simulator, and we can evaluate the performance of the simulated system. Moving further, this is the outline of today's video. I initially discuss about the available CPU models in gem5, followed by the memory models. Next, I will discuss how to run and configure real benchmarks in gem5, and at last I will provide some insight on solving the assignment 1 in gem5. As a quick recap of our previous gem5 videos, I have already discussed about the CPU models that are available. CPU models are designed with plug-in capability with arbitrary ISS, that is instruction set architectures, and memory systems. By this I mean that different CPU models can be integrated with the available memory models as in plug-in capabilities. As a tour to the gem5 directory, we have seen that the first directory specifies the architecture and the instruction sets architecture present in gem5. The second directory specifies the CPU models, and the third directory specifies the memory models. As a broader category of CPU models, gem5 supports two such models, in order CPU and out of order CPU. Now, I will go in details of the two CPU models supported in gem5. In order CPU model, which contains three such submodels, that is atomic simple CPU, timing simple CPU, or timing. And the next one is in order CPU. The name given to this model in gem5 is minor CPU. While there is just one out of order CPU model, that is O3 CPU or derives O3 CPU available in gem5. The first two CPU models are also known as simple CPU models, and the next two are known as detailed CPU models. Moving further, gem5 builds different memory components like the caches, that is L1 cache, L2 cache, main memory, DRAM controllers, and also the interconnection backbone. To implement the memory system, gem5 uses two memory models, that is classic memory and Ruby memory. I will defer the discussion of Ruby memory module in the next video. Throughout the assignment of gem5, we will use the Ruby memory module. The figure shows the interaction between gem5 CPU structure and the memory modules. In this video, I will describe only on the available CPU models, spatially O3 CPU or out of order CPU. The implementation of O3 CPU can be found in this directory. In CPU models, the atomic simple CPU and timing simple CPU are implemented as the conventional MIPS 5-stage pipeline. That is, the pipeline has a fetch stage, a decode stage, a execute stage, a memory stage, and a write back stage. The only difference between atomic simple CPU and timing simple CPU is that for an atomic simple CPU, all the operations related to an instruction is completed within a single cycle tick. On the other hand, in timing simple CPU, the timing behavior of memory accesses are taken care of. That is, the memory are being accessed in fetch stage and in memory stage. In fetch stage, the fetch delay, where the CPU brings instructions and data from the memory, is taken care of, while the memory delay during the mem stage is also accurately being processed in timing simple CPU. Hence, it is also known as timing module. In minor CPU and out of order CPU, each pipeline stages are modeled with accurate timings as in real system. The difference between these two models are the in order CPU is modeled as a 4-stage pipeline, that is, the first stage is fetch 1, the second stage is fetch 2, the third stage is decode stage and the fourth stage is execute stage. In order CPU or minor CPU, the program executes and fetches in order and it also executes in order. On the other hand, the out of order CPU is modeled as a 7-stage pipeline, that is, it has a fetch stage, a decode stage, a rename stage, an issue stage, execute, write back and commit. Here the program fetch occurs in order, the execution occurs in out of order and the commit occurs in order. In all the 7 stages in gem5, branch predictors are implemented in decode stage, we have reorder buffers implemented in rename stage and the out of order execution is taken care by scoreboarding that is implemented in execution stage. For further details of the O3 CPU and the other CPU models, you can go through this reference. We will use the O3 CPU for assignment 1. For all the assignments on gem5, we will use 4 benchmarks for the multi-programmed spec CPU 2006 benchmark suite, that is NAMD, Leslie, BZIP and LBM. The description of spec benchmarks can be found in lecture 1 of this course. Let us now deal with configuring and running real benchmarks on gem5. The configuration of the simulated machine that we will use for this video is mentioned in the slide. We will model a detailed out of order CPU where the number of core is 1, also known as a unicore processor. We will have 2 levels of caches, L1 and L2, where the L1 cache size including L1 data size and L1 instruction is of 16 KB and 2-way set associative. The L2 cache size is of 256 KB and 8-way set associative. In the example that I will show, we will use the benchmark NAMD. Interested readers can also implement the same configuration with different benchmarks, that is LBM, BZIP2 and the others available. The coherence protocol that we will use is Messi 2 level, and since we are using Ruby memory model, we will make Ruby is equal to true. To build the system, we will use this command. Go into the gem5 directory. In the gem5 directory, type the command sconce build. We will use alpha architecture and the binary that we will use is gem5.opt. We will make Ruby as true and protocol as Messi 2 level. And then we will specify the number of CPUs that we have. In the first video, I have already shown that the command ls CPU in a Ubuntu terminal will show you the number of CPUs that are available. In my system, I have 8 CPU. So, I will add number of CPUs plus 1, that is 9. After that, this command will build the Ruby memory system in the gem5. To run the benchmark with the configuration mentioned in the slide, we will type the following command in the terminal. Build will go to the alpha architecture that we have built, gem5.opt binary, configs example se.py. We will use se.py throughout our assignment. I will set -- Ruby flag, which will set Ruby as true. I have already mentioned in the configuration file that the CPU type is detailed or O3. We have only one CPU with the L1 cache size, that is L1 data cache as 16 KB, L1 instruction cache as 16 KB. The associativity for both the cache, that is L1 instruction and data, is 2, which can be set using these parameters. The L2 cache size is 256 KB and the associativity is 2. We use NAMD benchmark using this flag, and the number of instructions that we are going to simulate is 1,000,000. So, you can see that these have shown an error. So, on getting such an error, clearly look what the error is all about. Here the -- Ruby and -- CPU type should have been separated by a space. We again have another error as L1 D cache. So, in case if you get such multiple errors and you do not know where the error is all about, what you can type is a help command. This is available in gem5.opt. You can go to the simulation script, that is se.py, and type --help. This will show you the available parameters that you can support, such as you can see L1 D size, L1 I size, L2 size, L3 size, the associativities that we have typed in the terminal, the cache block size, -- Ruby, and there are various such parameters. So, now we got to know that our error is, it is L1 D size and not L1 cache. I have shown this so that you get to know what the error is all about and try to resolve it. This process is simulating our machine and the simulation is completed. Now, you can find the statistics in, go inside the gem5 directory, inside the m5 out directory, you will find the stats.txt file. On opening the stats.txt file, you will find that this is the number of seconds that our script have run on the simulated machine. This was the frequency that we have used, that is 1 gigahertz. The instruction rate per second was around this much. We can also see the demand misses that the L1 caches have experienced. Just type demand hits or misses, you will find that the L1 data cache have experienced around this much number of hits and it have experienced 2263 number of misses. You can also find that the L1 cache, the demand hit was around this much, and for the L1 cache the demand misses, the cache misses were around this much. So, these statistics will be useful in calculating various parameters during your assignments. So, the related files for assignment 1 can be found in this folder. This is the script where you need to make some parameter changes, and options.py contains the default values of L1 cache, L1 D cache, I cache, L2 cache and many more. You can find this in this path. And for assignment 1, we will use O3 CPU, Unicore processor, 2 level of caches L1 and L2. The coherence protocol will be messy 2 level and we will set Ruby as true. The L1 cache size will differ, the associative will be different, and we will also specify what will be the L2 cache size, its associativity and the benchmarks. By this, we come to the end of today's video. For any further queries, you can write us in the discussion forum of the course web page. Thank you.